Hello guys, Skipper here again, with part 3 of our ComputerCraft series that we're going along with here, and the second part of using turtles to create a branch mine for us. Well, they've already dug us some lovely shafts here, using the program we wrote last time, and now we want some side shafts here. Now, I've already gone through this and written a program, and we're going to hop over in a second to a program editor to have a look at it. But first of all, let's discuss how I went about it. Well, the first thing to consider is where is it going to start. So let's get some stone here. Right, I've decided that the starting point is going to be the same starting point as the shaft mining. So it mined this central shaft from here. It started on this block, and it went forward and it did the thing and it came back and it sat on the block again. So now, if we want to run the program, we want it to, from the same turtle, we can make it do these side paths. So, between each torch we have 1, 2, 3, 4, 5, 6, 7. So if we have the torch in the middle, we skip 3, or we have a 3 block between each. We get it nice and symmetrical. And we have a tunnel, then a 3 gap, and then a tunnel. Then 1, 2, 3, tunnel. 1, 2, 3, tunnel. 1, 2, 3, tunnel. So there we go. So even that took ages. If we do it for turtle, if we make the turtle do it, we can go off and do something else. So, these are the variables. The variables are, how long is the main shaft? And this is quite easy to measure from the end here, just by counting the number of torches down the edge. So, we've got a variable t, the number of torches, length of the main shaft. Also, we want to know whether it should dig tunnels on the left side, on the right side, or on both sides. So that's going to be f, the function. So 1 could be left, 2 could be on the right, and 3 can be dig both sides. Also, we want to know how long it should dig these side branches for. And that can be L, length of the side branches. And also we need to assign a number for the number of branches it's done already, and the total it expects to do. So, this is going to be quite a long program, so it's going to be a lot easier to edit it outside of just this prompt. So, I'll be back in a second, guys, when we have moved over to Notepad++. Okay guys, we're back, and we're in Notepad++. Which is a very nice text editor designed specifically to be used with programs, computer writing. And we can change the language up here. So we've got it in Lua, so it knows all of our little commands and stuff that comes with Lua. And we can change it with control and the scroll wheel. And we can even, with F11, go into full screen mode. So we're going to do that for now. So, let's have a look. These 2 dashes mean a comment. So everything after those dashes on that line, on line 1, is going to be a comment. So it's not going to take part in the program. Okay? So this is going to be the usage of it. Branches is the name of our program. So when we're going to run the program, we're going to type branches, space, 1 number, which is T, the number of torches, deep the main shaft is, F, the second number, which is going to be the function, L, which is going to be the length of the branches. So we're going to type branches, space, number, space, number, space, number. And we can sort all these numbers out using this. Arguments are in the brackets, these curly brackets. So, argument 1, the first number after the program is arguments square brackets 1, and we convert that to a number and call that number T, the number of torch depth. Same for F, same for L. And also, just at the start here, we're going to assign a value NE, number of elapsed branches. So that's the number of branches it's dug. So far it's dug 0, so I haven't started yet. So we've got lots of local functions here, because this program needs a lot of things to be repeated in a kind of manageable way. So we've got a program that creates this, that finds us the number of branches. So this is the total, returns the total number of branches that are going to be dug. And then we have initial setup, which moves the turtle to the start of the first branch from our starting place. We've got dig branch, which digs out the branch as long as we've told it to dig, and then returns the turtle to the end of the branch. Go to next branch, which moves the turtle to the next branch, taking into account which function is selected. That should be function. And finally the go home command, which sends the turtle back to the starting square. Okay, so we're going to first of all look at how are we going to find the total number of branches that are going to be dug. Well, if f equals 1, then the turtle is going to just mine on the left hand side. So for every torch, we saw before that it's going to mine 2 squares. So it's going to be the number of torches. Sorry, this should be, yeah. So the number of torches multiplied by 2 gives us the NT, the total number of branches that are going to be dug. Otherwise, if it's on the right hand side, same thing. NT is going to be number of torches times 2. If it's doing both sides, then between each torch it's going to do 2 on the left and 2 on the right. So T times 4. End. And that gives us our NT value for this program, which is the number of branches that are going to be dug in total. Then we have the initial setup function. So this moves the turtle to the start of the first branch. So from its starting square, turtle's going to move forward twice, and then turn left if it's doing the left hand side or both sides, and turn right if it's just doing the right hand side. Because when we're doing both sides, F3, function, third function, we're going to do left side, right side, left side, right side, left side, right side. So if it's doing just the left or both, it's going to start on the left, so it's going to turn left 1. If it's just doing the right hand side, it's going to obviously start on the right, so it's going to turn right 1, and then go forward, so it'll either go towards the first on the left or the first on the right. And then it's ready to go. So it's sitting in front of where it's going to start mining. Next, we're going to dig the branch. So this program here will dig the branch and return the turtle to the end of the branch. So as we've done before, we set a value a equal 1, and as before, while a is less than L, the value we set at the top here, so while a is less than the length we want, it's going to do this whole tier here. You can minimize that there. There you go. So it checks if the a value is less than our target length, and if it is, it will do 7 times I equals 1 to 7, dig, go forward, dig up, add 1 to a. So we end up here with a equals 7, or a equals 8 even. That's going to be what it's going to be. So it's done that 7 times, dug, gone forward, and then we want to place a torch. So because we can't just place a torch above where the turtle is sitting, because it will place it on the block in front and that will get destroyed, the turtle needs to go up, then dig out the block in front of it, then go back down again, then place a torch, and it will stick to the wall after selecting torches. So a prerequisite for this program that I should mention now is that torches are in slot 13, so the bottom left slot. Then that's that. So it's going to keep doing that until a is greater than the length we asked for. And it's going to do it to the nearest greater multiple of 7, because that's just what we told it to do. You can change this number to whatever you want, and it will do it to the nearest greater multiple of that number. So if we set our L equal to 5, it's going to do a 7-block long tunnel with a torch at the end. If we set it equal to 10, it's going to do a 14-block long tunnel with a torch at the end. And then, when it reaches the end of that, so after it's done this while statement, it gets to A is greater than or equal to L. A is greater than L. Then it's going to turn round, turn 180 degrees, and then for I equals 1 to A, so the number of blocks it's travelled, it's going to go forward that number of blocks again. So it's going to go back down the tunnel and then end. And then it's going to add 1 to the number of elapsed tunnels and then end. And that is our function of digging a branch. Next comes a slightly more tricky thing. So before we've done that, we're going to go and just demonstrate these 3 here. We're going to demonstrate these 3 functions. So I'll see you a second in Minecraft again. Okay, so I'm back, and we have here our turtle. I've programmed it in with our branches program so far. So we've got the arguments being set here, the number of branches argument, local function, the initial setup function, and the dig branch function. So, what can we do here? Well, we need to actually tell it to do something. So, what are we going to demonstrate first? Let's demonstrate number of branches. So, if we run number of branches, there we go, and then print digging space dot dot, so it will join these together in the return. Digging dot dot nt, total number of branches to be dug, space branches, and then that can be the end of our program. So if we go branches, and then we want to put in, 1 second, number of torches deep, we're going to go 1 torch deep. What function? Just on the left, and then how long? 7 long. Okay, it's going to dig 2 branches, which is correct because it's going to go 1 torch back, so back to here, and then only on the left, so 2 branches will be dug. Correct. Now, if we do branches, 1 torch deep, 2 torches deep, and the third function, 7 deep, so it's going to dig both sides 2 torches back. So, 8 branches, which is correct, because with the first torch back, it's going to dig 4, second torch back, another 4, total 8. There we go. Great. Now if we go back into edit branches, and we go back down to the bottom here, oh, no, over here, please. Oh, page down, there we go. Excuse me. So now, if we go up to number of branches, and we just delete everything that we've got after this here, we're going to do initial setup, and then we're going to print our digging space dot dot, oh, excuse me, dot dot nt dot dot space branches, and then we're going to do dig branch. And of course it's not going to do any more than 1 branch, because we haven't told it to go to the next branch yet. Okay, so if we save that and exit, and we do branches, 1 torch deep, just on the left, and we'll do it 5 deep to show that it will go to 7 blocks. So it will tell us it's going to do, oh dear, what's happened here? Okay, good fun here. Branches, line 48, attempt to call nil. Initial setup. Ah, because I put initial setup, not initial setup. Exit. Run that again. It'll tell me it's going to dig 2, but of course we've not told it how to get from here to here, so it's only going to dig 1. 7. And then is it not going to come back? What's happening there? That's not... I've done that wrong somewhere. Edit branches. Okay, so dig branch in here. It's going to place a torch up, and then what should it be doing after that? Well, let's try and write this now. So, what's this currently doing here? So currently, for I7, so currently this is while A is less than L, do. And then it ends that, and then it's got to go back. So, it's going to turtle dot turn right, and then do it again, turn right the way around. Oh, I keep doing that, what's wrong with me? And then, for I equals 1 to A, do turtle dot forward, and add 1 to the number elapsed, enter. So if we tell it to, we've only gone 1, haven't we? So if we go back 7, back you come, little guy. Oh, back 1, go back 1, turn right, go back 2. And then we do our branches program again. So, digging 2 branches. No, you're not. You're digging 1. Back you come. You should end up here. Oh yeah. A less than 1. Whatever. Okay. So we can prove that these things work here. So now we're going to go back into our editing program, and we're going to write the next bits of the program. See you in a second, guys. Well, I'm back, and, excuse me, here we go. We've done our digging, our setup, and our number of branches. So now we want to know how to go from one branch to the next. So this function here is quite a beefy one. So let's break it down into parts. So, this if statement covers almost the whole program. So, it's going to do different things depending on which function has been chosen. So for the first function, for just going down the left-hand side of the hole, it's going to come out and face out of the end of the first tunnel it's dug. Then it's going to turn left, go forward 4 blocks to skip 3, turn left again. So now it's facing into the wall, ready to dig the next tunnel. For I equal 1 to 4, 4 iterations, go forward 4 blocks. So, if f equals not 1, if f equals 2, then turtle's going to turn right, coming out of the wall instead, go forward 4 blocks, turn right again, turn right again, and now it's facing into the wall on the right hand side, ready to dig the next tunnel. This is where it gets a bit more complicated, because if we wanted to do both sides, then it has to know whether it should cross the tunnel and go to the other side to dig from left to the right, or whether it should cross the tunnel back again to dig from right to left. So the way we can do this is using this here, this modulus operator. This works out, this returns whether number elapsed divided by 2, it returns the remainder from that. So, if the remainder of number elapsed divided by 2 equals 1, so for example, if the number elapsed equals 3, then we have, then we have 3 divided by 2 equals 1 remainder of 1. So we have, e.g., 3 divided by 2 equals 1 remainder of 1. So if that is true, if you have a remainder of 1, then that means that we've just done an odd number of branches. So after the first branch, ne equals 1, because at the end of dig branch, we add 1 to NE. So it starts at 0, end of the first branch, NE plus 1, NE is now 1. So dividing 1 by 2 gives us 0, remainder 1. Gives us 0, remainder 1. So this is true. So then, for 2 iterations, twice, it's going to go forward. So it's just going to cross the main shaft to the other side, ready to dig on the right hand side. Else if our remainder is 0, so it's dug the first one, gone across the corridor, dug the second one, and now NE equals 2. So, e.g. 2 divided by 2 equals 1, remainder 0. So the remainder is 0. So if the remainder is 0, then it's going to turn right, because it's coming out of the right hand side, and it wants to go up and start the left hand side again. So it's going to turn right, move 4 blocks, turn left, cross the corridor. Okay? I'll just leave this on screen for a bit so you can have a little look at that. So it's going to turn right, go 4 blocks, turn left, and cross the main shaft again. And that's the end of all these statements here. Because now it knows what to do to go to the next one if it's on the left, on the right, or doing both. There we go. So, last thing, how do we get it to go home at the end of all of its business here? So, this sends the turtle back to the starting square. The first thing we want to do is it's sitting just next to the wall at the mouth of this most recent tunnel. It's going to go forward 1, so it's now in the middle of the main shaft. If it's been digging on the left, we want it to turn right to face back towards home. If it's been digging either the left or both, it's going to be on the right hand side. If it's been digging either just the right or both, then it's going to end up sitting on the right hand side, so we want it to turn left to face towards home. End. Now it's facing the right direction. Bye-bye. You're facing the right direction now. Now, if it's been doing only one side, so only the left or only the right, then the number elapsed is going to be how many tunnels down it is. You see what I mean? Whereas, if it's been doing both sides, then for every tunnel's distance down the main shaft it's done, NE is going to be twice as big. So, we're going to change the number elapsed. If it's been doing one side, either the left or the right, then we're going to change NE to NE minus 1. If it's been doing both sides, we're going to divide NE by 2, and then take 1 from it. So now we end up with a value of NE which ignores the first row it dug. So if it's done 3 rows on the left, if it's done 4 rows on the left hand side, so 2 torches, NE is now 3. If it's done 8 rows, i.e. 2 on both sides for 2 torches, so 4 on each side, it's going to be NE divided by 2 minus 1, which is going to be, 8 divided by 2 minus 1, 3. So again, we have 3 and 3. That's that done. Now we've converted NE to the correct value for the next bit. So, this is actually the statement that moves it the correct distance backwards. So, it's going to move forward 4 times our new value of NE from here, plus 2 blocks. So I'll go back, when we go back to Minecraft, I'll explain what this means, what this does. So, but this whole business here means that it will move the correct blocks forward. And then we're just going to get it to turn on the spot, so it's ready to go again. And then, finally, we have our run here. So, we run the initial setup, which, as we can see, gets the number of branches to be run. So, it generates the value of NT that we're going to be using in just a second. And then, for 1 less than our total number of tunnels, it's going to dig a branch and move to the next. We can't just run it for the total number, because we don't want it to go to the next branch after digging the last one. Otherwise it'll end up in the wrong place. So we do it for 1 less than that, and then we dig a branch. And then we tell it to go home. And then it's the end. So let's go over to Minecraft again and have a look at all of this in action. See you in a second. Okay, so here we go. We've done it. We've given it its program to do. We've told it what we want to do. Now, to explain what the distance coming back thingy was all about, these are the squares where it's going to start its tunnels. Okay? So now I'm going to set it running, and we're going to go for one torch, both sides, so function 3, and we're going to do them just 7 long. Okay, so here we go. Branches, one torch, both sides, 7 long. So, it's going to go down, dig a tunnel, place a torch at the 7th block. Lovely, come back. It knows to go to this side because it's only done an odd number, so the remainder is 1. Dig in over this side here. There we go, another one. And now, because it's done an even number, it knows to go right, go 4 blocks, turn left, go across. Amazing. So, now what? Well, it's going to do this one, and then do the last one, because this is the last time it's told to go to the next one, and this is our extra digger tunnel. So now, it's only going to want to do, dividing the two, isn't that beautiful? There we go. So, it's going to go out here, and then it wants to move 1, 2, 3, 4, 5, 6. But it only wants to go 4 blocks, 1, 2, 3, 4, once, whereas it's dug 2 rows. So we do the number of rows minus 1, add 2 blocks. Simple as that. So let's give it a slightly more daunting task. Let's turn around. Turn right 2. Go forward 5 maybe? Let's try that. Oh, perfect. Here we go. So new starting spot. Don't need to put the stone there, just to let you know. So hopefully it will dig tunnels in these places here. 3. Okay, and so on and so on. So we're going to do branches. How many torches down there? We've got 1, 2, 3. 3 torches. And we're going to do both sides. And we're going to do the tunnels 7 long. Off you go. Lovely. Well, there we go. I'm going to put a link in the description below to the code, paste bin of the code, so you can read it, copy it, do whatever. See, it's picking up all these gubbins, all the sandstone and stuff. So, yeah, I've been Skipper. I hope you've enjoyed this. I don't really know what we're going to do next time. Oh, I've got a jetpack, by the way. I cheated. I've got a jetpack. I don't know what we're going to do next time, but we're going to look at using these next time, at least. That's going to be one thing we're doing. And then, I think we might do... I don't know, we might make... I don't know what we'll make. Any suggestions of what you guys want to see made, or what you want to have a look at next time? Really appreciate any feedback on these episodes. As you can see, it's gone through this first torch, and now that. So, I've been Skipper. Please hit the like button, or favourite, or subscribe. It really helps. Not that I'm going to make any money off this, of course, but of course, it's good to know that it's helping people. There we go. I'm just going to, in fashion, watch it go to the end of its run here. I hope to see you next time.